What's going on, guys? It's Eric from Intelligent Quads coming back at you with another video. In this video, I'm going to be going over how to send movement commands to your drone using Pymavlink. So without further ado, let's get into the video. So we're going to be starting off in the Ardupilot documentation, and we're going to take a look at the suggested commands used for moving the drone. So the couple commands that Ardupilot suggest you use for sending the drone to waypoints in guided mode are the set point position target local NED command, and that is obviously using the local reference frame. Then there is the set point position target global, which then uses lat-long altitude coordinates. And then there is the set attitude target, which this would be used if you're trying to implement a controller at the attitude level, not if you're trying to give simple go-to commands. So in this video, we're going to be talking about the global position command as well as the local NED command. So that being said, let's go ahead and open up our text editor and let's go ahead and start getting to work. So the first thing I'm going to do is go ahead and make a new file called movement.py. Great. Now I'm going to go ahead and go over to the takeoff program that we wrote and go ahead and copy all of the connection commands, which are the first few lines. Go ahead and copy those in. And basically what we're doing here is, again, establishing the connection to the drone, and we're using the UDP connection on 14551. So for this program, we're going to assume that the aircraft is already in the air and we simply want to just send it to a target location. So the first message that we're going to be looking at is the local target position. So let's go ahead and take a look at the Ardupilot docs and take a look at what is all in the fields of this message. So the first thing is the time since boot, which in Ardupilot, this doesn't seem to have too much effect from my testing. The target system and the target component, which we'll get from the connection, basically auto-filled in from when we made our connection to our vehicle. And then the coordinate frame. So there are a couple coordinate frames that you can choose from, which are listed below the message definition in the Ardupilot docs. The one that we're going to be using is the Mav frame local NED, and this is in reference to the EKF reference frame with reference to the EKF origin, which is the first position in which the Kalman filter gets a good position estimate. The next thing we'll talk about is the type mask, which I'm going to save for later because this is a very key concept that you need to know when you're doing drone development. And then we're going to be filling in the XYZ coordinates because we're going to be specifying the positions that we want to go to, skipping the rest of the fields, and then going down to the yaw and yaw rates. So now let's go ahead and go back to our program and start filling in this message. So the first thing we're going to type is the connection.mav.send. And in the send, we're going to be specifying the message we want, which we're going to be using the mavutil.mavlink, and then .mav link with a capital L, and then underscore set underscore position underscore target underscore local underscore NED underscore message. Now we're going to simply fill it in based off the definition that we just looked at, which the definition is the time since boot, which I'll just set this to any random number, 10 milliseconds. And then we want the target system. So we'll use the connection dot target system. And then the next one will be the target component. So the connection dot target component. And then this is where we use the reference frame. So we're going to be using this reference frame, which we can call by using the enum, which is defined within Mavutil. So type in Mavutil, and then .mavlink, and then .mav underscore frame underscore local NED. All right, I'm gonna turn on text wrap here. And then the next thing is the type mask, which I will just type this in for now, and we can come back and fill this in a sec. And then the next is the XYZ position. So I want to send the drone to 10 meters in front of the drone. So that'll be in the NED coordinate system. X will be pointing out the front of the aircraft. So we'll go ahead and specify 10 meters and then 0 to the right. And then we have to go and look at the way this coordinate frame is defined for the Z coordinate. So in NED, positive numbers are down for the D component. So if we want the drone to be flying at 10 meters, we need to specify that as negative 10 meters. So we'll go ahead and pop in a negative 10 for here, and then we'll go 0 for the velocity X, 0 for velocity Y, and 0 for velocity Z. The reason why we're keeping these as zeros is because in the type mask, we are going to specify ignore the velocity set points. So let's go ahead and take a look at the definition one more time. So it's XYZ, VX, VY, VZ, and now 3 for the accelerations, which we're also going to leave as 0. And then now we get to the yaw set points. So for now, let's just leave the yaws as zeros as well. So that'll be, 0 for yaw and 0 for the yaw rate. All right, perfect. So now let's go ahead and talk about the type mask. So here they have already specified a couple different type masks that you might want to use if you want to use just the position or use just the velocity or the position plus velocity type masks. And essentially what this is if, say, you're using the position, you're going to want the zeros for the position of the variables that are in that field. So for the first one, if you want to use X, you'll set that to 0 because this type mask is specifying which fields to be ignored, right? So in these, we're going to be using the position. So those will be set to use, and then we'll use ones to specify ignore velocity. So there'll be 3 for that. And then there'll be 3 for the accelerations, which we're also going to ignore. And then there is going to be a 0 here. And so this one is a little bit of a tricky thing here, because essentially if you're looking at this definition of the bits that are in this field, you'll notice that after the 9th one, which is Z, they skip bit 10, which I'm pretty sure bit 10 is just not used in Ardupilot. So they just set it to 0, and then go to bit 11, which is the yaw, and then bit 12 for the yaw rate, which we're going to be ignoring. So if you really wanted to look at what this bit here means, you can come to the Mavlink definitions and then go to the definition of the type mask, or the bit type mask. And essentially it has all of these here, and the 10th bit is this force set, which I'm pretty sure this is not implemented in Ardupilot, and that's why they're kind of glossing over it in this documentation. So now let's go ahead and set this in our program. So we're going to be using the position bits. So let's go ahead and just copy that, and then we'll come to where we typed in type mask, and then we're going to just go ahead and cast our bits to an int, and then paste those bits straight in there. And this should be all we need to send our vehicle to a position. Now let's go ahead and start up our software in the loop simulation. So let's go ahead and make a few terminals. So let's go ahead and make 4. And in the first terminal, let's cd to the folder drone, and then we'll go ahead and run sim vehicle.py, and then -- r Ardupilot with a capital C, I believe. Ardupilot, I believe. Oh, wait. It's -V and then Ardupilot. And then while that's launching, let's go ahead and cd to wherever you have ground control, which for me is in my downloads folder, and launch that up. And then in the third terminal, we'll be running our script that we just made. So we'll go ahead and set this to guided, and then we'll wait for this to become green. All right, so now that the aircraft is ready to fly, let's go ahead and command takeoff from the ground control station. So now you can see the aircraft is taking off and going to the set point. All right, perfect. It looks like we're at the set point. So now we should be ready to run our program. So let's go back to our terminal, and then we'll type in Python 3 and then movement.py. And you'll notice the aircraft is moving forward. So this basically just shows you how to send movement commands to the aircraft. Now we want to know, how is the aircraft doing while going to this movement command? So for that, you can use one of two messages or both. So for that, there are two messages that I like to use to figure out if the aircraft has reached the destination that I desire. So let's go ahead and go back to our program real quick. And we'll write a while loop. And in this while loop, we're going to listen for the Mavlink message nav controller output. All right, boom. So now I'm going to go ahead and change the target to 20 meters away, and then we'll go ahead and see what this program does. So let's run this one more time. So what you'll notice is the waypoint distance basically started off at 10 meters away, since 20 meters was 10 meters away from where we started. And so it went from 9, 8, 7, 4, 1, and then we basically got to 0 waypoint distance because we reached the waypoint. Another message you can use to verify if your aircraft has gotten to the desired position is the local position NED message. So let's go ahead and take a look at that. So in this one, we'll send it to 30 meters. Now let's go ahead and see what this looks like. All right, so let's review. So basically, we started at 20 meters in the X and negative 10 meters in the Z. And over time, we basically converged at 30 meters in the X and negative 10 in the Z. So you could write a if statement to basically detect when these positions got to the desired position. Now let's go ahead and talk about the yaw fields within the set point target local NED message. So there are two different yaw fields within this message. So there is a yaw target and a yaw rate. The yaw rate is used if you want your drone to constantly be turning in a direction. The yaw target is if you want the aircraft to be facing a certain direction. So for this example, let's go ahead and set a yaw target for the aircraft to go to. And so the way that we're going to do this is, since yaw is the second to last one, we're going to set that bit to 0, and then we're going to specify a yaw target. So I'm going to go ahead and type in 1.57, which is about 90 degrees. Then I'll also set this to 40 meters so that it'll move forward and then also have the aircraft face to the right. Let's go ahead and run this and take a look at Q ground control. So boom, the aircraft is facing pretty much to the east and move forward 10 meters. Now we can demonstrate how it would look like if you specified a constant yaw. Now let's go ahead and set 1 for the yaw set point and 0 for the yaw rate. So I'll go ahead and set this to 0.5 radians per second, and then we'll go ahead and run the program once again. So now you can see the aircraft is constantly moving to the right at 0.5 radians per second. So the last thing I want to go over is the set point global target, which let's go ahead and take a look at the documentation one more time. So we're going to be taking a look at set point position target global int. And now we're going to be writing the equivalent of what we just did for local in the global frame. So let's go ahead and go back to our program. And we'll go ahead and copy this line right here and comment it out. And then we'll paste in the line here. And instead of using set position target local, we'll use global int. And just to make sure, set position target global int. Yep. And now we'll start going through each of the fields. So in set position target global int, we have the boot time, target system, target component. Those are all the same. Now the coordinate reference frame is a little different. So let's go ahead and take a look at what we want to be setting here. Right. So in this one, the frames are just described right here. So for this one, I want to be using the map frame global relative alt, and this is relative to the home position. So let's go ahead and specify that. Okay, so now let's go ahead and take a look at the type mask for this. So we're going to be using position, so I'll just go ahead and copy in the type mask for that and paste that right there. And then let's take a look at the lat and lon. So these are in integers. So what they've done is they've actually taken the latitude, longitude, which would normally be a float, and they've multiplied it by 1e to the 7. So let's go ahead and find a position that we want the aircraft to fly to. So the easiest way for me to do this is to go ahead and take, specify a waypoint, and then I'll go ahead and take a look at all the values, and then copy the latitude value here. So right here, which would be latitude, I'll go ahead and paste that in, and then I'm going to multiply it by 10 to the 7, and then we're going to cast this to an int. And we're going to do that the same thing for the longitude. And let's go ahead and look at the definition for our altitude. And it looks like in this, it's relative to the start position. And I believe that the altitude actually does need to be positive in this reference frame. And then we're just going to be ignoring all the rest of the fields. So this should work for what we're going to do. So let's go ahead and run our program and see what happens. And it looks like the aircraft is going to the waypoint, which matches up with what we specified here. All right, guys, I hope you enjoyed this deep dive into some of the commands you can use to send your drone to places in Ardupilot. In the next videos, we're going to be going deeper into Mavlink and Pymavlink, as well as the Ardupilot system. But until then, keep it classy.